How you doing today, class? Today we're going to talk about scientific notation. Today, class, you'll be able to take a number in standard form and change it into scientific notation, and vice versa. Here's an example of what scientific notation looks like. Now, what is scientific notation? Scientific notation is a very short way to write a very large number or a very small number. This number is very large. This number is very small. Rules for writing a number in scientific notation. A number written in scientific notation has two parts that are multiplied. The first part is a number greater than or equal to 1 and less than 10. Second part is a power of 10. Write the number in scientific notation. First, we got to place the decimal point where it starts and where we're going to put it at, or where we'll end up to write it in scientific notation. It moved over 9 slots, so very simple. It's 2 and 5/10 times 10 to the 9th power. Not 2.5 times 10 to the 9th power, but 2 and 5/10 times 10 to the 9th power. Write the number in scientific notation. This number is very small. So this is our start. And we're going to go ahead and move it over as many times as we need to put that decimal point in between the 5 and the 6. So therefore we moved it over 7 times. So therefore it's 5 and 6/10 times 10 to the negative 7 power. Yes, teachers do make mistakes sometimes. We are not perfect. Again, 5 and 6/10 times 10 to the negative 7 power. When do I know if the exponent is positive or negative? Well, that's simple. You check out the standard forms. Like it says here, the number in standard form is equal to or greater than 1 for a positive exponent. For a negative exponent, the number in standard form is less than 1. Let's do some examples. Where's the decimal point? Where is it originally at? You guessed right. It's at the end. This number is very large. Now we need to put this decimal point between. Read the following. Yes, you guessed it. In between the 7 and the 8. Went 9 spots. So therefore, the correct way to say this is 7 and 856 thousandths times 10 to the 9th power. Again, that is 7 and 856 thousandths times 10 to the 9th power. Here's a very large number again. Where's the decimal point? Read the following. And you guessed it, should be in between the 6 and the 7. So therefore it went over 7 places. So therefore 6 and 7/10 times 10 to the 7th power. Ooh, change of. This number is very small. See where it starts at? Read the following. Yes, you guessed it. It goes in between the 4 and the 6. Now we read this as 4 and 6/10 times 10 to the negative 6 power. Again, 4 and 6/10 times 10 to the negative 6 power. Ooh, very small number. Don't be confused. Decimal point. Where is it? Where do I need to put it at in order to have this in correct scientific notation? That's right, in between the 8 and the 7. So, that is 8 and 75 hundredths times 10 to the negative 9 power. Again, because we're moving it to the right, very simple, it will be negative. If I move the decimal over from the original to the left, it'll be positive. From scientific notation to a large or small number, you will move the decimal point as many places as the exponent tells you. If you don't have enough digits, just simply add zeros. We're going to move this 5 places to the right because the exponent is positive. So this number is large. So once you move it, again, replace the missing spots with zeros. And now you have it as 345,000. Ooh, negative exponent. That means we're going to move it 4 places over to the left. Again, any empty spots, you just simply replace it with zeros. And there you have a very large number. Let's do some examples. Here's the answers to these examples. Now, today, you'll be able to do this in class today. You have a good day.